So in this session, I want us to talk about introduction to arrays. We've spoken about arrays a number of times up until now, but I just thought I would specifically talk about arrays in this session and nothing else. Okay. So when you create an array, or when you you are asking for consecutive memory. I think we've shown this picture before. Just show it again. That when you firstly you create an array with number 6 there, line number 6, with the square bracket. Okay, you specify the type of data the array is going to contain. In this case, it's going to contain integers. You give the array a name. Remember, always give variables sensible names. And then inside the square bracket, you specify the number of elements the array is going to have. Okay. A language like C is, or let's just put it this way, arrays are, you've got to specify upfront the amount of memory you want for the array. Okay. Unless you are initializing your array with a where you specify, like in line 5, I want an array to store the letters H and I. Okay. So in this case, what you're going to have is this array is going to have 3 elements. It's going to have H. It's going to have I. It's going to, in other words, it's going to have the character H. It's going to have the character I, and it's going to have the character null, which we said is. Let's just write it next here. So we have H. We have I. We have /0, also known as null. Okay, /0 is null. Okay. If you go back to your ASCII table, it's the first character on the ASCII table. And for characters, just change it to an I. That's an I. I don't know why. Oh, sorry, my caps lock is on. Okay. For characters, or for a string always ends with null as the last value. Okay, so this array has got 3 elements: H, the I, and null. Okay. When you're initializing it and you say HI, you don't have to specify. You don't have to write the null. It's assumed that the terminating character of any string is /0. So if you create an integer array, you specify. Remember, integer array does not end with null. It's character arrays, or it's strings that end with null. Yeah. So when you create an integer array, you're specifying in this case that I'm looking for space to store 2 integers. Let's look at this one again. I'm looking for space to store 3 characters: H, I, and null. So this last one would contain null. Okay. Okay. So that first one will have H, the next one will have I, and then N2 will have, and N2 will have null. Okay. So remember, the first, when you are accessing an array, when you're accessing the individual elements of an array, you use the name of the array, square bracket, and the first index of is at index 0. And obviously, if you've got 3 elements, the last index is at, so if let's say I have X elements, in this case, X equals 3, then the last index is at X minus 1. So 3 minus 1 is the last one. Okay, that's essentially how arrays work. So let's look at this second one. We've got an array called nums that takes 2 integers. So there is nums starts over here, and there is the first space to store the first integer. There is a second space to store the second integer. Okay. We have also said before that, remember, the smallest addressable unit is 1 byte. If you want to store 2 integers, each integer is going to take 4 bytes. So in other words, it's going to occupy 4 spaces in 4 addresses in memory. Okay. And you need 2 of those. Okay. One for the first one for nums 1, and the second for nums 0, and the second one for nums 2. Okay, so let's go ahead and let's create that. Int nums 2, and I'm not gonna, okay, I can print the addresses, print f. Okay. So first, let's print the contents of num0 and num1. Nums 0 contains %d /n. What does nums 0 contain? It contains nums 0. Okay. We can check we can compile and run. Okay, nums 0 contains 16. So if you can see in this code here, there is nowhere where we put the number 16. And then let's print and check what nums 1 contains. Nums 1 contains, okay, nums 1 contains 0. Okay, so this 16 is a garbage value. So unless you initialize your arrays yourself, you cannot trust that. You have no certainty to know what is inside there. Okay, we've talked about. We've said before that this is the same for variables as well. Int x. X contains x. Okay, so in this case, x contains 0, but you have no guarantee that x will be equals to 0. X could be any number. It could be that 16. In fact, if you look over here now, all of a sudden, the 16 is at nums 1. So, and then we can check the address of x, the address of nums, the address of printf. Address of nums 0 is % nums 0 /n. And print that. num0 is at that address, okay? Even nums itself, okay? The word nums is pointing to nums 0, okay? So if we didn't have this ampersand to get the specific address of num0, but we just wanted to print what, just show you there, okay? So num0 is pointing to the same place as nums, okay? In other words, the name of the array points to the address at the first index of the array, okay? In other words, if you look at this, when I'm looking for that 266, I can get that number 266 either by the name nums or by the address of num0, okay? The word nums is pointing at 266. The address of num0 is 266 as well. Okay. And to initialize an array, you have to initialize every element of it. So nums, so if I wanted to give them the value 0, nums 0 equals 0, then I have to go and do the same thing, nums 1 also equals to 0, okay? So obviously, I mean, in this case, my nums is only equals to, I only have 2 variables, okay? And then let's print again the contents of nums. Okay, so nums 1 was 16 before, it is now 0 because we have specifically initialized it. So if, yeah, I don't think I'm going to say anything more than that. If you don't initialize your arrays, they are going to have garbage values. They're going to have values that you didn't put there. Okay. So in the case of this one, I only have 2. Okay. If this was 12, it would be a little bit tedious for me to say nums 0 equals nums 1 equals. So something like this, initializing an array is best done in a loop. So I can say for int I equals 0, I less than the size of my array in this case is 12. I could have declared the size of the array before that if I wanted to. In other words, I could have said int size equals 12, or I could do this line 3 hash define size and then put the value. So I could say hash define size 12. Okay. So in other words, I'll just write it hash define size 12. Okay. Then instead of this 12, I can say size, and then here I can say less than size. Okay. Or if I wanted to, I could create the variable here called int size equals 12. Okay. And then use, obviously, as you can see, this is small letter size, so I would have to put the small letter size there. Okay. So any of those works. I plus plus. Okay. And then I can say the name of my array is nums at I equals to 0. Okay. So this is going to say nums at 0 equals 0, nums at 1 equals 1, nums at etc. Okay. And then if I want to print the value of those arrays, I could just do another for loop. Okay. So int I. Okay. So this variable I over here, in this case, I have created this variable I inside this for loop. And so this I and that I have got nothing to do with each other. Okay. This is I is local to this for loop only, okay, or is visible to this for loop only. So if outside this for loop I say I should get an error saying we don't know what I is. Okay, so this I and that I are totally unrelated I's. Okay. And then in this case, I can now print printf. Well, I can just copy this one. Let's copy that. And I can say nums %d, nums, I'm going to replace this with I. I, and contains %d, I'm going to replace that with I2. Okay. Let's compile and see if we didn't make any error. Okay, let's run that. Okay, so there we go. Nums at 0 contains 0. Nums at because we've just initialized all those values to 0. Okay, and if I wanted to capture those in using an array, I could also use using a print and a scanf that says please capture value for nums at 1 and put it in 1. I could run a for loop just like this one, though with those statements as well. Okay. So I could say, what do I want to do? I want to printf. Please enter nums %d. So in other words, either nums 0 or nums 1. And then what do I want to do? I want to scan that %d. I want to scan %nums at I. See if we didn't make a mistake. Compile. And so we're going to have to do this 9 times. Let's run that. Please enter nums. What is? Oh, please enter nums. We forgot to put I here. Okay, let's run that again. Please enter nums 0, 5. Please enter nums 1, 45. Please enter nums 2. Okay, so the last one is please enter nums 11. So remember, if there are 12 nums, the last one is nums 11. Okay, and there they are. We've gone through our array, and if you can see, please enter. Yeah, if you can see, you can check the last 2 we entered. Okay, 12 and 3. Okay, so all what we entered was captured in that array. I hope at this moment you pause yourself and create an array yourself and populate it with values and print out the values and not just watch me and assume that by watching you are following. Okay. So I'm going to comment this out. I'm done. That's all I want to say about one-dimensional arrays. We have said before that we create, we use arrays as well to create strings. So if you want to capture a name of 50 characters long, so remember the total number of this one is going to be 49 letters and null at the end. So we use arrays to capture input. To use a string. So in printf, we can say, like, if we wanted you to enter your name, please enter your name. In, and then we can scanf %s, and here, because we are going to store that in the whole array called name, the address of the whole array called name is either name or, so if we use the word name, we don't need the ampersand. Okay. And scanf is looking for the address of the array name. The address of the array name is the variable name for arrays. Okay, because the name of the array points to name at 0. Okay, and then we can print that out. Printf. Good day. %s /n. Your name is name. Okay. Where is that scanf that continues in that array? I'm just gonna comment that out because I don't feel like entering a name 12 times. Okay. Okay, let's compile and let's run. Please enter your name. Sibusiso. Okay, let's go to the top. And it's a good day, Sibusiso. Okay. That's all I'm going to say about one-dimensional arrays. Okay, so I'm going to comment this out right now. And then I'm going to talk briefly about two-dimensional arrays. A two-dimensional array it's like an Excel spreadsheet. It's an Excel spreadsheet. It's rows and columns. Okay. That's all that a two-dimensional array is. Obviously, the way a two-dimensional array is stored in memory, there aren't, you can see what memory is like. It's just addresses next to each other. Okay, it's like a long list of addresses. Okay. So it's only a matter of how C interprets 2D arrays in memory. Okay. So I will start by, okay, let's just see. Okay, so we're going to create, and we're going to talk about creating an array for the class SFD150S. Okay, so I've defined there at the top the size of the class and the number of tests. Okay, it's not really enough. Okay, in other words, the number of rows I'm going to have 30 rows, and I'm going to have 6 columns. Okay, so just like Excel, I'm going to have a number of rows down, number of 30 rows and 6 columns. Okay. In my case, each row is going to contain data of each student. The columns is going to contain the headings for each. So in other words, my first column is going to be the student number, T1, test 1, test 2, test 3, test 4, test 5. Okay. That's what I've got the 6 columns for, and that. Okay. So so there I create my array, and with this statement, I'm going to have, as I said, I'm going to have 30 rows and 6 columns. Okay. So the way we visualize Excel, or rather the convention for rows and columns for Excel, is that the first square bracket is for row number, and then the second one is for column number. Okay. This is a C convention. Okay. As I said, in memory, there's nothing called rows and columns. There's just a list of addresses. Okay. But the way we refer to them in a way that everyone understands what we mean by what is inside the first square bracket and what's inside the second square bracket. As I said, so if you forget which one comes first between rows and columns, just think about the way Excel stores refers to data, and just remember that C is the opposite of how Excel does it. Okay, so in Excel, we refer to cells as A1. You never call a cell 1A, you call it A1 or B1 or B20. Okay, so if we come back to Excel, this cell over here is H5. Okay, so in other words, in Excel, H5 means column H, row 5. Okay, so when it comes to C, C reverses that. Okay. When we refer to, in other words, when I say SFD 150S 05, okay, I mean row 0, column 5. Okay, so we go row first and then column. In Excel, we go column name first, and then row number second. Okay. So as I said, if you forget which one comes first, just say, I know how Excel does it. In C, it's the opposite of Excel. C does not count rows and columns the same way that Excel does it. It's the reverse of that. Okay. Then you don't ever have to worry about remembering which one comes first. It's the opposite of Excel. So once I do this, I've asked for space in memory to store 30 rows and 5 columns. Okay. So before we get into the code, I'm just gonna let you visualize in memory what line 66 looks like. Okay. So this is how it's stored in memory. Okay. So in memory, I say I'm looking for 30 rows with 6 columns. Okay. So essentially, I am looking for a space to store, what's 30 times 6? 612. I'm looking for a space to store 180 integers. Okay. Each integer is 4 bytes long. Okay. So this is how it is. This is how this is stored in memory. Okay. Row 0, column 0 is stored at the first address. Row 0, column 1 is stored at the next address. Row 0, column 2, next one, up until row 0, column last. Okay, in this case, it's column 5 because we started at column 0. Okay. Then the next address is for the second row. Okay, second row is row 1, column 0, etc., etc. Then it continues all the way until I get to SFD 29, 29, which is going to be the, not 29, 29, 29, 5. Okay. In other words, row 29, column 5. Okay. That's how these are stored in memory. Okay. I hope you are able to visualize that. Okay. And here in line, so obviously we want to initialize each and every one of those. Okay. And to initialize it, I'm going to use a for loop. So I'm going to have the inside for loop initializing each row. Okay. And then after so in other words, each column in a row, column 0, column 1, column 2, column 3, column 4, column 5. Okay. That's what this for loop is doing. But obviously, once I've initialized for that column, I now need to go to, so once I have initialized for that first row, the 5 columns of the first row, I need to move to the next row number to repeat the same thing for the next row. Okay. Row 0, initialize column 1, column 2, column 3, column 4, column 5. Then move to row 1. Then in row 1, initialize column 0, column 1, column 2, column 3, column 4, column 5. Okay. So this is obviously best done using a for loop inside a for loop. The inside for loop is for initializing the 5 columns in a row. The outside column is for going through the 30 rows in that column. Okay. So once I've done this, I've gone through the entire 180 elements in that array and have initialized them. Okay. And then let's come to this next one. Here I'm now, I wanted to populate these values in the, I'm going to use, I'm going to ask someone to enter each of the details. So in other words, I'm going to ask the person to enter their student number, and I'm going to store their student number in column 0. Okay. I'm going to use a while loop and the for loop. Okay. So I'm going to use a while loop in this case because I don't want to do all 30 of them. I want to do either all 30, or if someone decides to quit before so if the lecturer is tired of entering the student marks and wants to quit before getting to all 30 students, then they can always enter a yes or no to continue. So I'm going to check if the lecturer hasn't entered yes or no to quit. Okay, so that's what the outside for loop is for. And then the inside for loop is for capturing the marks for T1, T2, T3, T4, and T5. Okay, and then I take the marks of each of those and use this I over here. There's T1, T2, T3, T4, T5. Okay, so I'm starting at I equals 1 there because I've already done. I've already captured for column 0 and put it there. Okay. So I don't need to capture for column 0 again. And also just a reminder, this I and that I have got nothing to do with each other. This I is declared inside this for loop and doesn't exist anywhere else besides that. Okay. And then I capture that, and to avoid anything being in the input buffer before I check whether the person wants to continue or not, I'm just going to flush the input buffer. To flush, get rid of whatever is in the input buffer, of input buffer data. Okay. So in other words, that scanf is going to have an enter that was not consumed. So that enter might be lingering and be consumed by the getChar. So I'm just flushing anything that exists there before I do that. Obviously, I want to increment n in this case, because I am going for n, I'm continuing as long as n is less than class size, so that we don't capture more students than the size of our class. Okay, done with that. And then here we are printing the contents of that array. Okay, so if you can see, the way we capture the contents of the array is similar to the way we initialized. The way we print the contents of the array is similar to the way we initialized the array. Okay, I think I actually copied and pasted from when we initialized the array. Okay. So we want to, line 100, we want to print the student number. Okay. And all that this 9D here is, it makes sure that it allocates 9 spaces to print the student number. Okay. So even if the student number happened to be 0, okay, but we are going to have 9 spaces nonetheless, okay, so that the things I print are below each other. Okay. And so line 100, we print the student number. We know that we're starting at I equals 0, going all the way up to class size. So in this case, we're printing the whole class. Okay. But if you wanted to only print the number of students that are there, so instead of class size, you would use this n variable here. Say I less than n, I plus plus. Okay, and we're going to do that. So we're going to print we're going to print the value of the 5 tests. Okay, so and the first test is in column 1, because with the column 0 contains the student number. Excuse me. And then we print that. And then for each test amount, we're going to allocate 5 spaces to print the test. And what's these are called filled width specifiers. This number 5 is not, it's saying the width of the field where I'm printing that number. It's 5 spaces long. Okay, it's 5 characters long, so that when I print the one below, all of them are directly below each other. They are all the same size. In other words, whether the person's mark is 0, which is 1 character, or 50, which is 2 characters, or 100, which is 3 characters, for each of them, I'm going to set aside 5 spaces to write that. Okay. And then after printing each of them, then we print a new line so that we can visualize that on the new line. Okay. So let me see if I can run that. Enter student number 1, 2, 3, 4, 5. Enter marks for the first person. Let's say the first person got 1. Test for marks 1 are 1. Let's say 50. Let's say 70. 10. It's fine. Let's say 4. You got 100. You got 90. Okay. Do you want to continue? Yes, I want to continue. Enter the second student. Let's say the second student is 987. Enter the marks, and let's say that first one you scored 100. Okay, and what? And 1. And this was a really bad test. You scored 9, and you scored 100 again. okay, for test 4. And let's say also for test 5, she's got 100. Okay. Do you want to continue? Let's just do one more person. Yes, I want to continue. Let's say 5544. And marks, let's say you got 20, 30, 60, 70, and you got 2. The last one. Do you want to continue? No, I don't want to continue. Okay. So we printed these. Let's go up to the top. Okay. So if you can see, this is where our filled with specifiers help. We've allocated 9 characters to store the first one. We've allocated 5 characters to store the second one. So if you can see, T1, 1, 2, 3, 4, 5 characters are set aside to store T1. 9 characters are set aside to store student number. This is 2, 4, 6, 8. There's one more space left to store that. That's what that %9 did. Okay, this is what the %5 did, and this is what this one was also %5. So if you didn't specify the width of each of these fields, you would have no way of guaranteeing that all these numbers are going to be below each other. Okay, and that's it. That's what we did there. We captured and we printed to see if there was anything else I wanted to say about. Okay, this I've already showed you the addresses of these, but we can print them for you to see. Okay, but I don't want to be capturing that input there. Okay. Okay, so if you can see from here, let's just scroll down to it. That the address of 00 is %00, which is at 296 at that, and then the address of the next one, 01, it's at 4 bytes later. Okay, at 300. 2, 4 bytes later, 4 bytes later, 4 bytes later, 4 bytes later. And then if you look at the second row now, 10, okay, %10, it's 4 bytes later. So showing that indeed what I showed you in Excel is true in memory. Okay. Excuse me. And here we're just doing that same thing, but just using a loop instead. Okay. Because hopefully you can see how tedious, excuse me, it is to be doing that. I mean, here we're just doing it for the first row and second row, just the first column. But if you wanted to print all 180, typing all this is quite tedious. Okay, but writing it in a loop, it's as simple as just specifying, look, I want to print the address at I and J, and I'm gonna loop through this allows me to loop through the columns, and this allows me to loop through the rows. But even here, I'm not going to do all 30 rows. Then if I can do 3, I can do 30. Okay, it's the same. Let's run that. Okay, so this is just for the first 3 rows. Okay, you can see 96, 300. Okay, let's go to the edges of let's go to the end of the first row. First row ends at 05 at 16. Second row starts at 20, 4 bytes later. Okay, we can check the same thing with the end of the second row. Second row ends at 40. Third row starts at 44. Okay, I hope you are now convinced in terms of how they are stored in memory and how to use two-dimensional arrays. Okay, and that's it. I'm gonna end there.